Domain and range. Have you heard the terms domain and range for the function?
No.
Is that yeah or no?
No.
Okay. No, it's not too hard. Okay. So when we talk about, you know that all our functions have inputs and outputs, right? And the inputs are generally what? The x's, and the outputs are the y's. All we have now is a different name for inputs and outputs. Okay? That's the only thing new here, is instead of saying input and output, mathematically, the terms are domain and range. So the domain of a function, right? Whoops, did that always do that? It's like the domain of a function is all of the inputs that could possibly be put into, the equation or what have you, right? So that's generally the x's, or t's if you're doing something with time or whatever, right? But the inputs, okay? That's domain. Range is all of the outputs, which are usually represented with what? Y's, or f of x's, or g of x's, right? Okay? That's all that is. Now, there are some functions where you can put any x in that you feel like, right? Any number that exists in the real number system, right? But some of them, maybe it'll only work with integers. You know what integers are? What are integers? You never heard the term integer?
No, I have. It's been like 3 years.
What about whole number? What's a whole number?
A number?
Huh?
No.
Yeah, it's not a decimal fraction, right? It's like 0, 1, 2, 3, like counting numbers, right? Okay? So whole numbers are like the positive counting numbers, right? Integers are like whole numbers, but it's all the positive and negative whole numbers, okay? And then sometimes your inputs are like, you know how we restrict things to an interval, like from x is from -3 to 3? Then those are your inputs, -3, -2, right? That's your domain. It's just those numbers, right? From -3 to 3, okay? Those are the inputs that you're going to use. And the range, of course, is when you put those numbers in, the stuff that comes out is the range, which will be measured by the y-axis, right? It's your graph, okay? So it's really just two different names for the same things we've been doing, okay? So let's look at this example here. We've done this quite a few times, right? You see our function over there? Okay, the graph. And it looks like it starts and stops. It looks like it has a particular set of inputs. Where do the inputs go from? What to what? What axis are you looking at for the inputs? Okay, so that graph represents the inputs from what to what? From what number to what number? You just count. Negative, right here, right? So from here, is that -5? -5 to what? To 3. So the domain for this particular function, this graph, the domain, all the inputs are x values from -5 to 3. Okay? And then, of course, the range is from what to what? What's the lowest number for the outputs? -4. And what's the highest number for the outputs? So the range goes from -4 to 5. All right? So inputs to outputs, domain, range, all right? So what is the value of f of -3? And f of -3, what's the output for that? If your input is -3, Anna, what's the output? Find -3 on the x-axis and go either straight up or down to the graph. 1, right? So -3, the output is 1. All right? Amy, What is the output for f of negative or f of 1? -3. Input 1, output -3. All right, Keegan. What is the output for f of 3? Five, right? Might be easier if you look in your book, right? 3 goes up to 5. Okay? So what we did is we entered some possible values of our domain, our inputs, right? And got out values of our range, the outputs. Okay? What's that? Okay. All right, part B. Can the function rule, given by the graph, give you a value when x equals 5? What do you guys think? Why not? Yeah, they start and stop the graph before it gets to 5, right? So you don't know. I mean, you might like to assume that it goes on with that pattern, but you can't because they stopped it on that interval, right? On that, so in other words, the domain does not go out to 5, right? That make sense? So the answer is no. The domain, right? Inputs only go from what to what? From -5 to 3. In other words, this, okay? So this is one way to represent our domain. You've seen that before, right? X, our inputs, are between -5 and 3. T. Yes. What? The what? I don't know. There's no way of knowing that. Okay? All right, part C. Is x equal 5 in the domain of the function? I think we kind of already answered that, didn't we? Huh? No. We kind of answered it, right? Because the domain only goes from -5 to 3, so the answer is no. Wouldn't we just say it is outside the domain? It's outside the domain or set of inputs that are possible. Okay? All right, on to part D. So give two other values of x that are not in the domain of the function. Just tell me, in other words, two other values of x. You see this here? Not in that domain. Just choose two numbers that are not between -5 and 3. What's that? Yeah, x of 7 is not in there. And x of -4 is in the domain. Did you say negative or positive? Negative's in there, right? 4 is not in there, is it? Right? Yeah. Oh, I got you. Yeah, yeah. Okay. All right. So those are outside the domain. Right now, we've just been talking about the domain, right? All the possible input or x values. All right, part E. Circle the following y values that are in the range, right? So range is measured on the y-axis, isn't it? Okay, because that's the outputs, the y's. So let's see. Y values that are in the range. Is y equals 0 in that range?
Yes.
It is, isn't it? What about y equals 6? No. Y equals -1. I'd say, oh, I circled that one. I don't know why I did that. Y equals -1. How about y equals 3? That's in there. Y at -5. Okay. And y at 4. No, because what is the domain? What to what, we said? The dome, or I'm sorry, what is the range? I'm sorry. -5 up to here. Wait, wouldn't 4 be in there? What is the domain? What is the range? 1, 2, 3, 4. Oh, that's -4. Okay, yeah, I miscounted. I thought it was -5. So -4 up to how high? So this is -4 up to 5, right? Okay. Anything outside of that, we say it's outside the range. Okay. So let's write it in notation here. We already did it up there for the domain, right? Give me the domain as an inequality. Basically the same thing we wrote up there. X, I'm just going to write -5x. I'm going to write -5 and then the number 3. Guys, you wrote it down up here. Yeah. X. Less than or equal to?
3.
3. Thank you. Okay, let's do the same thing for the range, except we're not going to use X. What are we going to use? What? Y. So give me the range. -4 less than or equal to Y to 5. In other words, Y, the range is in between -4 and 5. Get the idea? No? Is that a yes or no? No? Domain is inputs. Range is outputs. The only thing new is a name for inputs and outputs, Stephen. That's it. All right, next page. Sometimes you'll see it represented like this. Okay? I think it's kind of silly, but I've seen it done like this before. But again, the domain is all the possible what? Inputs or X's, right? Ranges, outputs, or Y. Or f of X in this case. Okay? So here's our rule, our function, right? And here's all the inputs. Okay? So let's find the range for this particular domain. You notice that this domain is pretty restricted, right? It's not that it goes from -4 to 10, right? It is specifically just -4, just 6, and 10, and that's it. No numbers in between. When you see it like this, you get the idea? And so, how many outputs would this have then? 3, right? To correspond with each one of these, yeah? Okay, so let's figure out the range. So if we put in -4 for that x, right? So it'd be -4 over 2 minus 3, right? What's that? -2 minus 3, which equals what? So -5. Okay. Let's find the output for 6.
Good.
Go ahead. What's -4 divided by 2? And then minus 3. Yeah. Okay, so this equals what? 3 minus 3, which is 0. Corresponds to the 6, right? And let's do the 10. 10 over 2 minus 3, and that's 2. Okay? So it's like, I mean, you could kind of draw your lines here, right, and make them correspond. And this is a function, right, because every input has what?
One.
Exactly one output, all right? So what is, now, let's look, we're gonna list the range in what's called set notation with the curly brackets. Okay, so all we do in set, I'll just say this is set notation. Right, we can't really use the inequality less than, right, because that would include all the numbers in between, wouldn't it? So we just specifically list the range. And that would be what? -5, comma, 0, comma, 2. They don't do it over here, but let's do the same thing with domain. -4, 6, 10. So you see this set of domain entries? Goes with that set of range entries there. Okay? So this is called set notation with those curly brackets like that. Okay? Let's move on to exercise 3. What does that say? Do we have a function? Well, a graph is a function, right? We don't have it as an equation, right? But oftentimes we can just use the graph and that's our function, right? We got inputs and outputs. Okay, and what's the question? Not in the domain. Not in the domain. The x's, right, of the function. So which one of these? So the x's, the domain goes, let's write down the domain. This one we can use an inequality, right, because it's continuous, as they say. It's not just individual one, so it goes from what to what? So let's write that. Is it -5? Less than or equal to? 1, 2, 3, 4, 5.
It's not -5 less than or equal to x.
Goes out to 4, right? So that's our domain. Okay? So now when you write it like that, it's kind of easy to see which one of these would not be in the domain.
5. Well, I'm saying answer 3.
Say the actual number it is. 5 would be outside the domain, wouldn't it? Choice 3. Okay? All right. What do we have in exercise 4? What do we call this type of function, guys? Hard. What's another word for hard? You mean piecewise?
Difficult.
Okay. Or piecewise. It's off.
Huh? It's called a piece.
Piecewise function. We've done a crap ton of them.
We did it like yesterday or the day before.
Probably all the days. Yeah.
I wasn't here.
And I have another beef with this one.
Beef?
Mm-hmm. Do you see this thing where it's listed? There's the part of the function, and this is, if you had inputs between here and here, you'd use this top one.
So you don't want that equal.
Yeah, I want to ditch one of those, right? Yeah, well, good. So you learned. I told you you'd be a good math student. There you go. Let's see. So, -4 to 2 inclusive, right? But then this one's also 2. What the heck? Yeah, so I'm just going to make an executive decision, and I'm going to make this equal sign go away. Okay? So, those are called the domains, right?
Did you get rid of the other one by the 4?
No, that's fine, because they don't share it, right? They don't share it, so I'm not worried about it. Follow me?
Yeah.
I'm sharing them because, like, when I get to 2, like in a table of values, like, which one would you use if they both include 2? It doesn't make sense, right? So this is the set of possible x values, which we call the domain. It's a D. I don't want it to look like pomain because I know someone will get confused. Why did you write pomain? D. D. Okay? So when you see these intervals with x's in it, you could also call that a domain. And each one of these pieces of our piecewise function has its own domain, doesn't it? Okay? So we need to find the range. The range is all the outputs, right? Isn't that? Okay. So let's make a table. The tables they do are always vertical, right? Let's make it horizontal. So let's do it like this. Domain. Well, not much I can do about that. And I'll call this range or Y, like this, okay? I'm going to do like that. And let's list some of the integers in the domain. It goes from what to what? What's the lowest between both of those pieces, the piecewise? Right. All right. So what's the lowest value between the two of them together? What's the lowest input value possible? I guess by lowest I mean smallest number. The lowest number in those domains.
-4.
-4. And what's the highest one?
4.
All the way out to 4, right? So -4, -3. Just do this. 3, 4, right? Okay? Yeah, I just got tired of doing the vertical tables. Doesn't really matter, does it? Neither. Okay. So when we do -4, which of those are we going to put it into? The top function or the bottom one? The top, because it falls into this top domain, doesn't it? Okay. So I could mess this all up with calculations and stuff here. Another way to do it is with the graphing calculator, you make a table of values. So let me just, I'll save you some time. Save us all some time here. I'm going to list the output values. So let me ask you this. Because you guys know how to plug in a calculator, right? We have to keep doing that every time. Okay. So of all these values, we know -4 will go in the top one. What's the last of these that'll go in the top one? 2. Yes, because it includes 2, right? So from here to here goes in the top one, right? And the other ones go in the bottom one. I might want to do 2 in both of them maybe, right? Just like if they don't meet up, I do want to see where the end point of that one is, right? Okay. So when I put a -4 in, just copy this down here. I get a 1, I get a 1/2 or a 0.5, and then I get a 0, and then a -0.5, and then I get a -1, -1.5. Whoops. Why is that doing that? And then I get a -2 and a 2 and a 6. Okay? I'm pretty sure you guys can all plug those into the proper one and get those outputs. Okay? All right, so here's your X and Y's. Everyone right now, while I'm doing it, don't wait for me, plot these points, right? Maybe you need a straight edge to draw your line with, okay? So everyone do that right now. Let's read this. What was it? Oh, yeah, 6. So the plot about like that. look up at mine. You guys plot your own points. It's on your page, right? You copied the table down, right? Didn't you? You don't need to look at mine. Just plot your X and Y's. And connect them with a nice straight line. There. And then there. Okay? Give you a second to do that. Okay. First Regents question. Cammie, would you read that first one for us, please? Paramecia. You know what a paramecium is? Microscopic. What about an amoeba?
I've heard of it, but I don't know
They're little microscopic, or what single-celled organisms, right? And paramecium is just one type. But anyway, go ahead. Exponential. 3 times 2 to the t power. And we'll do exponential functions later, but what an exponential function is, it just has a variable up in the exponent, okay? We don't need to worry about that too much right now. Go ahead.
T is the number of days the population is first. Which operator is most appropriate to use to determine the population over the course of the first week?
Okay, let's think about this. So domain would be all the inputs, right? If you look at this function, what is the input stuff? What gets, it's not x's, it's what? The t, time, right? Hold on. And the time is measured in what? Oh yeah, I got this stupid thing. Number of days, right? Because these single-celled organisms, they just start splitting. They reproduce by splitting in half and making new ones, right?
And they die.
I don't know, but they just, not really, no. So you input a number of days, and out comes a new number of these parameciums that you have, okay? So which domain, so t is the number of days, and they want the domain over the course of what? First 2 weeks. Do you see an issue here? Okay. So then tell me which of these choices, 1, 2, 3, or 4, is correct domain.
Probably
Time from what to what? Come on. From 0 to 2 weeks, right? So which one's correct? Not 3? That's why I was pointing out, did you see an issue here, right? Because they want 2 weeks, right? But that t is time in days, right? So this is important to know. 7 days in a week. So that's 14 days, right? So the appropriate domain would be from 0 to 14, okay? Or input values. Okay? Let's think about number 2 and talk a little bit about the different types of numbers there are, right? Ms. Ennis, would you read number 2 first, please?
A dolphin jumps out of the water and then back into the water. His jump could be graphed on a set of axes where x represents time and y represents distance above or below sea level.
What does that mean? Hold on. So distance above or below sea level. So just picture, right? Dolphins jumping out of the water, the surface of the water to sea level, right? Out and back. So he's above sea level, and he dives back in. He's below sea level, right?
He would be positive when he's out and then negative.
Yep, positive when he's out, negative when he's below. Yes, that makes sense. So what would be an appropriate domain? Well, what's the input here, by the way? Okay, domain, remember, is input. Does the domain represent a positive or negative distance above sea level? The domain represents what? Time, x, yeah. So really, you were correct about that, but we're not, that would be the range, wouldn't it? Is height above or below sea level? They want the domain, and it's time, isn't it? So which one of those would be appropriate?
Wouldn't it be positive?
Positive integers, so like one, what is the time in, what did we say? Say it's minutes. So 1 minute, 2 minutes, nothing in between? You're right, it'd have to be positive, right? Because we're not gonna go back in time and measure the dolphin. Choice 2, positive integers. So just 1 minute, 2 minutes, that's it? Not 1.3 minutes? What about even seconds? Yeah, the real numbers are all the integers and all the infinite stuff in between, right? Yeah. Right, for like fractions of a second, huh? Be choice 4. Yeah. Okay, and you understand why it wouldn't just be the integers, like the whole numbers, right? Yeah, because there's going to be the times in between. Yeah. Okay. Hannah, read number 3 for us, please.
The grocery store is selling packages of beef. The function CFW represents the cost in dollars of the package of beef, weighed 11 pounds. The most
No, 11?
W
W. Okay.
W pounds. The most appropriate domain of the function would be.
Well, let's think about it. What's the domain? The cost or the weight?
The weight.
The weight, that's the input. You know, more pounds means an output of more money that you have to spend, right? So the domain would be pounds. Well, let's see. You guys have been to the deli or maybe the meat section, and,
Yeah.
you know, get 2 pounds of ground beef, right? Well, those are your only options: 1 pound, 2 pound, 3 pounds.
Like 2 point something.
Oh, okay. So we can eliminate integers, can't we?
That's going to be positive rational numbers, or just rational numbers.
Well, rational numbers can be negative.
So positive rational.
Yeah, positive rational numbers. Right? There you go. For pounds. Because you can have 1.23 pounds. Yeah. Huh?
You're gonna have half or something.
Ground beef?
Oh, yeah. Oh, I was talking
Half
about
pound of turkey.
Yeah. Sliced ham? Right?
Ham's gross.
Whatever. Ham's gross.
Ham's disgusting.
Maybe you got the wrong type of ham.
You gotta go for turkey.
I like the ham potato thing.
Honey baked ham.
Yeah, I know.
That's good. Okay. What's our function up here? Skylar, read number 4, will you? Skylar, read number 4.
X equals 2x plus 6x minus 12. The domain consisting of integers from -2 to 1 inclusive.
Okay, hang on. Let's write that down. -2 to 1. Write that as an inequality, will you? Okay. Think about this. Hold on. Are we going to use an inequality, actually? Why not? It's integers. So no in-between numbers, no decimals, right? So how could we write that? Look how they have these.
They just have it.
In set notation, right? So don't we kind of have to list them out? Okay, so our domain, I'll just put D, would be -2, comma what?
-1,
Yep,
comma 0, comma 1.
so that's our input.
So that's
I see.
-2.
-2 to 1, and only integers. So no, 0.5 or anything like that. But they want the what?
The range value?
The outputs, right? Right?
Yeah.
So what do we need to do to get the proper outputs that go with each of these inputs? Isn't 0 an integer between -2 and 1?
Hannah, what number is in between -1 and 1?
So how do we get the range, the outputs that go with the corresponding domain or
When you plug
inputs?
it in,
You plug each one of them in, right? Right? You could do it real, we don't have to be too formal, right? So let's do -2. 2 times -2 squared, plus 6 times -2 minus 12. That is what? What's -2 squared? 2 times 4 is what? So that's 8 for this part. 6 times -2.
minus
Minus, 12 minus 12. What's 8 minus 12 minus 12?
-16.
8 minus 12 minus 12. Whoops. Oh, what did you say?
-16.
Oh, yeah, I'm sorry, you're right. -16. So there's one of them.
So the answer's 2. Oh,
I don't know.
or 4.
Let's put in -1. 2 times -1 squared minus 6 times -1. What was it? No, minus 12, yeah. What's -1 squared? 1 times 2, so it's 2. What? Oh, it's plus 6, sorry. 2
I was so confused.
No, that would be -6.
minus 6 minus 12 gives you what? You don't sound too sure. That's what's 2 minus 6. And then -4 minus 12.
-16.
Oh, -16 again. So that's in there twice. Now, I will say, if it shows up twice like that in set notation, you only list it once. So let's try 0. 0 squared plus 6 times 0 minus 12. You better just tell me what this is immediately without thinking at all whatsoever.
-12.
-12, right? And let's do 1 real quick. Squared. So that's what? 2, 6 minus 12. 8 minus 12 is -4. So what's our choice? You see how 16 showed up twice, but when you list it in set notation, you only list it one time?
Yeah.
Okay. All right. Number 5. So there's a function. It's in graph form. The domain. This function is
-1.
is it all
-1 to positive infinity. Because there's an arrow.
-1. Is it inclusive? Does it include -1? Why? How do you know that?
Because it's a closed circle.
Closed circle.
What if that's a positive infinity though?
Yeah, we go from -1 all the way up to positive infinity, right? Is it going to be? It's not going to be integers, right? Because there's, right? Obviously, the line goes in between numbers. So which choice is it? Which one? All positive real numbers? Wait, we got a negative here, don't we?
Oh, so I was gonna say choice.
Choice what? You guys don't sound too sure about it.
Or because it has the 1.
Remember when we did the thing like from something less than x, less than infinity? I told you the other way to write it. It's just x is greater than the first thing,
Yeah.
which implies infinity, right?
See, I told you. It
So
was
choice 4. Let's flip the page here. And by the way, we'll cross out number 8. That should not be there. Everybody cross out number 8.
That looks easy.
It is not, because you need to know the quadratic formula and need to be able to calculate its determinant.
What? I don't have.
That's why I crossed it out. We're not there yet.
No, 6 is easy.
Yeah, it's easy. All right. So we have function f of x equals x squared. Domain 0, 1, 4, 9. What's its range? So this is like the other one we did. If this is the domain, what do you do to that to figure out what its corresponding range is?
Square it.
Just put them in there. You can do that in your head, couldn't you? Everyone take a second right now. Tell me what the range is.
Choice.
Well, let's set them.
3 and 4 kind of the same. Oh, no, they're not the same.
Not quite. So you want to do 0 squared, 1 squared, 4 squared, and 9 squared. What's 0 squared? 1 squared, 4 squared,
16,
9 squared,
81.
81. God, thank you. Nobody said 4 squared is 8 and 9 squared is 18.
Ah! Well, 81 is 18.
Yeah, that's correlated. So what choice? 0, 1, 16, 81. One more. You guys read it on your own. What do you guys think? Choice 4, irrational number, like so it could be a decimal.
Yeah. It is a decimal.
Okay, what's the problem about though? What are the inputs? What are the inputs? What does C stand for?
Oh,
Columns. So choice 4 makes sense for a domain if your domain is the possible number of columns. Why not?
But you can't sell like 4/5 of a cone.
Yeah, right? You can only use whole cones, right?
I mean, you can.
Only whole cones are involved here, what you would assume, right? I think that's a safe assumption. You could, but I don't think that customer would come back. So, what's our choice? So, okay, integer, yeah. Less than 0. So you can sell negative cones?
no, it'd be greater than or equal to 0.
Yeah. Oh, I couldn't hear you. Mumble.
I do too.
Say it with more confidence. Remember, if you, whatever you say, if you say it confidently, whether you're right or wrong, people will
Well,
believe
Karen was yelling too.
Yeah, you know, I'm gonna say with confidence. I hate